Hello, today we're going to take a look at practicing polar graphs by doing a matching activity. So here, this can be found in a PDF on It's Learning, and if you would like to try this out and then come see how you did, that's okay. If you want to just walk through how I would do it, that's fine too. So we have 15 equations, graphs, then the names and characteristics. So our equations, if we start with E1, we have R equals 3. So what we want to do is take a look, find in our graphs, there are a few graphs here, one where R is equal to 3. If we have no theta involved, it's just an R, we're going to have a circle with a center of the origin. So in this case, we've got G3 as our graph for this, and we know it's a circle. As far as characteristics go, well, we have some of the names there, and we want to take a look and see if there's one that matches up with a circle. And we've got R is equal to 3 is our equation, and so it's going to be C9 here because our radius is 3 and our denominator or diameter is 6. Now we try and find our equation E2. I mean, we've done E1, great. So we do E2. When we see an R squared, the first thing that we need to do is throw out everything that's not a lemniscate. We know we're looking for an infinity sign, and really the difference between E15 and E2, they're both lemniscates. They both have a radius of 5, or we'll say radius, or it's kind of like a petal length, or kind of tie of the bow tie, because if you square root that, that will give you your length. So it's just looking at the difference between the cosine and sine lemniscates. Oh, conveniently, they are right here. Our cosine is going to be G14 because just like with our rose curves, the x-axis is a line of symmetry for this, and the sine for G15 is going to be in between the axes. So G14 is our cosine. So E2 will be G14. And then E15 goes with G15. Okay, so we've used these 3. That's going to be helpful for not having to go back to those pages. So they are both lemniscates. And as far as characteristics go, the characteristics aren't necessarily as important here. And bisects 8 petals. This looks like we've got it's symmetric to these, and then the maximum R values. We'll come back to characteristics once we've ruled some out, but I think it's going to be C1 and C2, whereas we've got this one was C2, this one was C1, I believe. C2 goes with our sine. Oh, yeah, that's why. Helps if I write it in the right spot. All right, let's find our equation E3. So we have 5 minus 3 sine of theta. So 5 minus 3 sine of theta. We are looking for something that's symmetric about the y-axis, and 5 minus 3 is going to be a lemmasome. So it could be G5. Yeah, it's looking like it's going to be G5 because, well, let's actually write that in here before I forget. So we've got G5, and that is a limacon. Because when we look at this, we've got 5 minus 3 sine theta. The 3 tells us it's going to be symmetric about the y-axis. The 5 being greater says that we have a dimple or a dent instead of an inner loop. The 3 being negative tells us that most of the graph is going to be below the x-axis. And if we take a look at our values, this one, I believe it's supposed to be labeled that -9 is the bottom, but our outer loop, our bigger part, should be at the sum of the two numbers, and then our dimple, our dent, or if there's an inner loop, that is going to be at the difference. So that's why we have 8 and 2 here. And with characteristics, we don't have petals. Maximum R value equals 8. There we go. So we've got C14 for the characteristics. Let's take a look at E4. E4, all right. So we've got 5 plus 5 sine of theta. So we know that with sine, we've got the y-axis as our line of symmetry. 5 plus 5 sine of theta tells us we have a cardioid. So it's going to be G4. So with G4, 5 plus 5 sine of theta, the positive 5 that's being multiplied by sine tells us that most of the graph is going to be above the x-axis. Our greatest value is going to be the sum of the two numbers, so 5 plus 5 is 10, and then our cardioid, because they're the same number, will pinch back into 0 because the difference is 0. So we've got a cardioid for that, and then our characteristics, it's going to be this C8 here because it's all the things that we talked about. So we've got C8, and it is a cardioid. And this one is a lemniscate. All right, let's move on. See if we can find our fifth equation here. I'm not sure why these aren't in order. Okay, 5 sine of 3 theta. As we're looking at this, we want to look for a rose curve. So we know that this is a rose curve. I'm not sure why my pen is not cooperating here. So 5 sine of 3 theta. So we come and look at our rose curves, these 4 that we have, and well, we know that if our n value, so what's being multiplied by theta inside the argument of our trig function, if that is odd, we're going to have an odd number of petals. And it's going to be that exact number. So our 5 sine of 3 theta is going to be either G1 or G12. And we look to sine because G12 has the y-axis as a line of symmetry. So we have G12, and then let's take a look at characteristics. So we want to look for one that's talking about 3 petals symmetric to the y-axis. Okay, so we have C6. All right, we are moving along. So that means if we can find the other one, we may as well do it now, even if it's not E6. So E11, that 5 cosine of 3 theta, that is the G1. Same idea with the 5 being the petal length, the 3 telling us we have 3 petals, but cosine, it's symmetric about the x-axis. So that's what the equation is, 11, and it's G1. We've got a rose curve. Graphs go here, so it's G1, and then characteristics, then we've got the 3 petals, so it's C11 over here. So we're building this as we go, trying to find those relationships between these. Let's look somewhere else then. So if we go down to E6, 1 plus 5.5 sine of theta. We've got a sine of theta, so we're looking at one that's symmetric about the y-axis. So it could be G8, could be, well, rose curves are different. But the thing is, since B is greater than A, and we have that A plus B sine theta, it's going to be G13. It's going to be a limacone with an inner loop, where our outer loop is going to be the length of the sum of the two, and the inner loop is going to be the difference. So it's G13. And we've got a limacone. Then our characteristics. It's not going to be one of the ones with the inner loops, or with no inner loops. It's going to be one of these with an inner loop. Curve lies above the polar axis, so we've got C4. All right, going on to some of these equations. Well, honestly, while we're here, let's deal with E14. We know that since B is greater than A, we're going to have a limacone with an inner loop, except this one's going to be symmetric about the x-axis, which is right here, so our G9. So G9 goes with E14. G9, we've got a limacone. And our characteristics, we still have an inner loop, so we've got C10. So we're filling this in as we go, matching up the ones that are pairs of, oh, I can identify that that's a limacone with an inner loop. That's what the equations look like. So go with both of those together. Now, just like our limacone without the inner loop, if we look at E12, it's 5 minus 3 cosine theta. It's going to be that same sort of dimple as, or dent, as in E3. So E12 is going to be this G11. Same idea. We have 5 minus 3 cosine theta, so it's symmetric about the x-axis. It's to the left of the y-axis because the 3 is negative, and it has that dent because A is greater. So G11 goes with E12. And then our characteristics is this C3 because there's no inner loop. Let's take a look at what other equations we have. Well, just like with our cardioid over here, with sine, E8 has to be another cardioid because 5 and 5 have the same, 5 and negative 5 have the same absolute value. So E8, we're looking for a cardioid that is to the left of the x-axis, so that would be G10. So we've got E8 with G10. We know it's a cardioid. Come on.